To find the transfer function of a given network, so first method is block reduction method. An electrical network is given, and it's a simple network. Two resistance are in parallel, and there are four components. One is R1, R2, C, and inductor. And there are vertical components and horizontal components. Vertical components are capacitor and inductor, and horizontal components are R1 and R2. So to find the transfer function, what we require is it is V0 of S divided by Vi of S. So first we need to convert the given electrical network into S-domain network. For conversion, you can use Laplace transform. So the network we get is Vi of S, resistance remains as it is. Next we have, for capacitance it is 1 by SC, for inductance it is SL, and output is V0 of S. Now to write a block diagram for this, we need to consider some variables, and those variables are nothing but Vi of S, I1 of S, V1 of S, I2 of S, and V0 of S. And we need to create relation between Vi of S with I1 of S, I1 of S with V1 of S, V1 of S with I2 of S, and I2 of S is with V0 of S, so that it is nothing but a relation from Vi of S till V0 of S. Now in this case, we can consider two current. One is I1 of S in this loop and I2 of S in the other loop, and we can write the equation with respect to each other. Now since we have four components, we have four equations. So you can see that I can write equation for I1 of S first, and for I1 of S it is nothing but, the first equation is nothing but Vi of S minus V1 of S divided by R1. For V1 of S it is I1 of S minus I2 of S into 1 by SC. I2 of S it is nothing but V1 of S minus V0 of S divided by R2, and V0 of S, the current flowing across SL, that is the inductor, is nothing but I2 of S, so I can write it as I2 of S into SL. So I have four equations. Now if I want to convert this equation into block diagrams, you can see that Vi of S minus V1 of S indicates that I need to use a summer. Vi of S is positive, V1 of S is negative, and it is multiplied with 1 by R1. So if you consider this first one, you can see that Vi of S, and this is the minus sign, minus V1 of S into 1 by R1. And the output is I1 of S. The left part of side is always the output, and the right part side is always the input. Similarly, you can write it as I1 of S minus I2 of S into 1 by SC, going with the signal V1 of S. Again, the equation number 3, we have V1 of S minus V0 of S multiplied by 1 by R2, and the output is I2 of S. Similarly, the last one is, the output is V0 of S, the input is I2 of S. So in between the gain is SL. As you can see, this is the Vi of S is the input, output is I1 of S. In the second block, I1 of S is the input and V1 of S is the output. Again here V1 of S is the input and I2 of S is the output. Similarly, I2 of S is the input and V0 of S is the output. So we can combine all this block diagram into one block diagram, that is like this. So what we have here is, we have just combined all the block diagrams, and wherever there is V1 of S negative sign, there is a feedback symbol. As you see, V1 of S exists at this point, so I am writing a feedback to the summer. Again, I2 of S is fed back from this point to the summer. Again, V0 of S is fed back to this summer. In between we have different gains. One is 1 by R1, 1 by SC, 1 by R2 and SL. Now for reduction of this block diagram, what we can do is, I can shift this summer block to the left side, and I can shift this takeoff point to the right side. If I am shifting the summer block to the left side, then I need to divide it. already it is 1 divided by R1. If I further divide it, it is nothing but R1 block, and I need to connect R1 block to I2 of S. So in the second part, you can see that for I2 of S, I have connected R1 block. Now when I am moving the takeoff point towards right side, that is whenever I move the takeoff point towards right side, the gain should be divided. So I am combining that part as 1 by SL, and it is connected to the output V0 of S. The moment I move the summing block to the left side, there are two summing blocks which is in series, or you can say consecutive. So if such a condition exists, I can interchange the summing block. Why do we need to interchange the summing block? Because I need a minor loop in between. If I don't interchange, again it will be in the form of a mixed loop. So to do that, I have interchange, and you need to observe that Vi of S input remains as it is. I am only interchanging the connection. Instead of V1 of S, I keep it as I2 of S. Instead of I2 of S, I'll add the signal as V1 of S. So as you can see from this diagram. Now after this, it looks very easy. Why? Because these two are in series, so I can simply multiply 1 by R1 into 1 by SC. Again, these two are in series, so I can multiply SL by R2 if I multiply. Next, these two are in series, so it is R1 divided by SL. So the block diagram looks somewhat like this. Now further, when I solve this for minor feedback, as you can see, this is a unity negative feedback. It is nothing but 1, and we know the formula. Formula is nothing but G of S, and since it's negative feedback and it is minus 1, it is nothing but H of S. Here also it is H of S. If I further reduce this block diagram, it looks something like this. That is, I have Vi of S plus and minus sign, and if I apply the minor feedback formula, that is G of S divided by 1 plus G of S into H of S. Why it is plus? Because it's a negative feedback. If it was plus here, then it would be a minus sign at this point. Now again, these two are in series. Since they are in series, you just have to multiply. Again, there is a feedback, and feedback is nothing but H of S, that is R1 divided by SL. So the final answer we get is SL divided by S square L R1C plus S L plus R1 R2C plus R1 plus R2. This is one way of reducing the network and obtaining the transfer function. We'll go with the second method. The second method is nothing but Mason gain formula. In this, we are considering the same electrical circuit, and we are considering the same electrical equations, the network equation that we got from the circuit. Here, what you need to observe is, again, I1 of S is the output. Here, V1 of S is the output. I2 of S is the output, and V0 of S is the output. And this gain 1 by R1 is equally multiplied with respect to Vi of S and V1 of S. So the first equation I can write like this. So I can simply write a line Vi of S going towards I1 of S, and it is divided by 1 by R1. The other side is we have V1 of S, and it is negative signs because it is multiplied by 1 by R1 negative, and both are towards the direction of I1 of S, and I1 of S is the output. In a similar case, if you take the second equation, I can write I1 of S in this direction, and the gain it is multiplied is 1 by SC. It is minus I2 of S, so I2 of S is in the feedback. Since whenever there is a negative sign, it indicates that the summer block is getting a feedback. So I am writing a curve like this with sign of minus 1 by SC. Similarly, we can take V1 of S minus V0 of S divided by R2. So V1 of S in this direction, V0 of S in this direction, and moving towards the output, that is I2 of S. Again, V0 of S, we don't have any feedback here, there is no negative sign, so it is I2 of S, and SL is the gain. So V0 is the output, I2 of S is the input, and SL is the gain. Now from this you can easily see that I can write this part easily. Vi of s going towards I1 of s. Again I1 of s going towards V1 of s. V1 of s going towards I2 of s. Again I2 of s going towards V0 of s. So first I can write this diagram and it is shown in orange color. Okay, and I can write the individual gain. The first one is 1 by R1, the second one was 1 by SC, the third one was 1 by R2, and the fourth one was SL. So I have simply represented that. And for the loop we are getting this loop from V1 of s. So you just take that part V1 of s and create a loop towards I1 of s. Similarly, the loop is from I2 of s to V1 of s. So I2 of s to V1 of s. The next one is the loop is from V0 of s to I2 of s. So I can write V0 of s to I2 of s. And what is the gain flowing here? Negative feedback gain. That is minus 1 by R1, minus 1 by SC and minus 1 by R2. So minus 1 by R1, minus 1 by SC and minus 1 by R2. Now what is the advantage of Mason gain? Mason gain has given a formula. If we apply this rules to the system, we get the transfer function. So the formula given is, it is transfer function, that is V0 of s divided by V of s is equal to summation k is equal to 1 to n and tk delta k divided by delta. Here k is nothing but the forward paths. Forward path is nothing but the movement from input to the output. So if in this case there is only one forward path, that is I have from 1 to 2, 2 to 3, 3 to 4 and 4 to 5. That is a signal starting from input and reaching to the output, and it should not repeat. The node should not repeat. For example, I cannot consider 1 to 2, 2 to 3, again 3 to 2, again 2 to 3. So if there is a overlap of node, it is not considered as a forward path. In this problem there is only one forward path. If there are two forward paths, then you need to consider k as 2. Now t is nothing but the total number of forward path, and delta k is the non-touching loops linked with the forward path, and delta is nothing but 1 minus, you can see here it is 1 minus loops of individual. Here there are 3 loops. This is one loop, 2 to 3 again coming back to 2, this is one loop, 3 to 4 again coming back to 3, 4 to 5 again coming back to 4. So there are totally 3 loops in this system, there is L1, L2 and L3. So individual loops plus 2 non-touching loops. 2 non-touching loops indicates that if you take this example 2, 3, but I cannot take L1 with L2 loop because these 2 loops are touching with each other. Okay, and if I consider loop L1 and loop L5, these 2 loops are non-touching loops. So I can consider L1 and L3 as non-touching loops. Now if I take L2 and L3, these 2 are again touching loops. Okay, so I cannot consider this. If there is a condition of 3 non-touching loops in a system, then I need to consider that also. So for T1, it is nothing but the total gain in the system. And when we write the signal flow graph, we are not worried about I1 of s, V1 of s, I2 of s and V0 of s. Why? Because we are simply concentrating for T1 is the total gain of the system. In the gain process, we have 1 by R1, 1 by SC, 1 by R2 and SL. So T1 is 1 by R1, 1 by SC, 1 by R2 and SL. It is good that if you write the numbers for this and you consider all the numbers here. It will be easy for us to see which loop is touching the gain path, that is a forward gain path, and which loop is non-touching for forward gain path. So since k is equal to 1, the formula will be reduced to T1 delta 1 divided by delta. Okay. So I am rewriting the same signal flow graph as it is, and I have considered loop L1, L2 and L3, and I know that delta is equal to 1 minus individual loops, that is L1, L2 and L3, and non-touching loops, two non-touching loops, it is L1 and L3, because L1 and L2 are touching loops, L2 and L3 are touching loops. The only non-touching loops in this system is L1 and L3, so I am considering L1 and L3. So individually I'll pick L1. L1 is nothing but 2 and 3, and it is coming back, that is minus 1 by R1 and 1 by SC. So if I only concentrate the path, then I get 1 by SC multiplied by feedback path is defined with negative sign, so it is minus 1 by R1. So the final equation that I get is minus 1 divided by R1 SC, and you just write the numbers, that is 2 and 3 is the loop number. Next is L2. For L2 it is 3 and 4. Again the gain is 1 by R2 and minus 1 by SC. If I multiply these two, I get minus 1 by R2 into SC. Again the path is 3 and 4. For L3 it is 4 and 5, and it is minus 1 by R2. So if I write the loop, I can write this as SL into minus 1 by R2, and the final equation for this is minus SL divided by R2, and the loop is 4 and 5. T1, we already written the T1, and T1 contains all the node numbers, that is 1, 2, 3, 4 and 5. Now for delta, I just need to substitute for L1. L1 I got minus 1 by R1 SC, L2 I got minus 1 by R2 SC, L3 I got minus SL by R2. If I substitute all the things, again we have L1 into L3. I just need to multiply these two. Since in both the cases it is negative sign, I get a positive value here. So this is my delta value. Now what is delta 1? Delta 1 is a very important factor. Here it is nothing but 1 minus, we had L1 plus L2 plus L3 and plus L1 into L3. Is L1 loop touching the forward path? For example, I can simply compare this with loop L1. As you can see, in this path I have 2 and 3. Even here I have 2 and 3. That means it is touching, but I require a non-touching loop. Since this forward path is touching with loop L1, I can consider this as 0. Again, if I take the second case, I have 3 and 4. And even in this case I have 3 and 4. It indicates that this forward path is moving along with loop L2. So again it is 0. L3, again I have 4 and 5. It is 0. If L1, L2 and L3 is 0, its combination 100%, it will be 0 again. So I am left with delta 1 as 1 only. So what is this? Now I just need to substitute all the values that I know. In this case I have S, again in the denominator I have an S. So these two get cancelled. What is left is T1 is L divided by R1 R2 C multiplied by delta 1 is nothing but 1 divided by 1 plus 1 divided by SR1C plus SR2C plus SL by R2 plus L by R1 R2C. If I solve this solve this equation, I get the final answer like this. So in both the cases, in Mason gain formula as well as block reduction formula, we get the same transfer function because the system is same. So the transfer function obtained should also be same. And there is one more method that you can use. The moment you have written the block diagram, okay, you can, if in the examination, if the problem given is in the block diagram, and if you feel it is very difficult and in the exam they have not told that you need to use a block diagram reduction method, you can use either Mason gain formula also. Then it is always best that you convert the given block diagram into a signal flow graph, then apply the Mason gain formula. So this is the same problem that I am considering. So what you need to do is, first, for every summing block and take away points, you just have to give a name. So for summing block, this one I am giving name as S1, second one it is S2, S3. For takeoff point I am giving name as T1, T2 and T3. So these are all the nodes. So totally I have 1, 2, 3, 4, 5, 6 nodes. So I will be considering 6 nodes. And I will be connecting it as it is. So if you see, from S1 to S2 the gain is 1 by R1. So I am taking 1 by R1. From S2 to T1 it is 1 by SC. From T1 to S3 there is no gain, but I need to simply consider that line. Okay, and the gain will be 1. If there is no gain, I cannot consider it as 0. The gain will be 1. Next, from S3 to T2, it is 1 by R2. From T2 to T3, it is SL. Now, how the loop exists? The loop exists from T1 to S1. So, I am considering T1 to S1. Now, the second loop is from T2 to S2. So, I am considering T2 to S2. And the third loop is from T3 to S3. I am considering T3 to S3. Again, the formula is same. The formula is nothing but how many forward paths are there? Again, in this case, the forward path is only one because the remaining all are feedback paths. Okay. And k is equal to 1 forward path, and we have V0 of S divided by Vi of S. Since k is equal to 1, the formula reduced to T1 delta 1 divided by delta. Again, T value is the total forward path. If you compare with the previous method, I get the T1 as it is. That is 1 by R1, 1 by SC, 1 by R2 and SL. And you just number all the nodes, that is from 1 to 6, and you just represent it as it is. Next is loop. The loop here is, it is from 1 to 2, 2 to 3, again from 3 coming back to 1. This is one loop. Again 2 to 3, 3 to 4 and 4 to 5, and it is again coming back to 2. Again the loop is 4 to 5, 5 to 6, again it is coming back to 4. Okay, so whenever you consider a loop, it should start from the same node and should end at the same node. So the equations that I get is L1 is minus 1 by R1 SC, L2 is minus 1 by SC R2, L3 is minus SL divided by R2. So I just represent that numbers that is considered as a loop. That in this case it is 1 2 3, in this case it is 2 3 4 5, in this case it is 4 5 6. As you can see, when I compare with the gain, since the gain has all the node numbers, it indicates that all the loops are touching with or going along with the forward path. Okay, that means L1 is 0, L2 is 0, L3 is 0. Since L1, L2 and L3 are 0, its combination is also 0. So the only left out value is 1. Okay, and one more curious thing here is, it is like a determinant. Delta 1 is nothing but a determinant. It is like 1 minus individual loops plus, after minus I am getting plus. This is 2 loops, again I get minus 3 loops, again I get plus 4 loops. It goes on like that until, depending on the system that we have. Now when we substitute all this equation into the system, again I get back the same equation, same transfer function. Okay, this is the method 2. And one more important point that I need to add is, whenever you are reducing the block diagram reduction, you should not get square terms. So if I have, let's say I have G1 here and I have used some rules and I am getting a reduced block diagram, but I am getting the equation as G square, it is wrong. You should not get 2G1 or 3G1 or 4G1 or 5G1, something like that with a coefficient. Then you have done something wrong in the block diagram. These 2 points are very important.